Now we will see how to do addition of binary numbers, two binary numbers. In order to understand the addition of two binary numbers, we need to understand the addition of two decimal numbers. So today's topic is binary addition. Binary addition. How to do binary addition? Okay. So before going through binary addition, let me add two decimal numbers. From this addition of two decimal numbers, we can understand easily how to add two binary numbers. Okay. So for example, if I want to add two decimal numbers, 14 plus 28, for example. Okay. So if I want to add these two numbers, so 4 plus 8 is 12. In this 12, we consider 1 as the digit which need to be forwarded to the next significant bit. So we are considering this as a carry bit, and we are considering this as a sum bit. Because why we are considering this, we are giving the name carry bit for this 1, because so carry bit is a bit which is forwarded to next significant bit. Carry bit is a bit which is forwarded to next significant bit, next significant bit during addition. Okay, so what is meant by carry? Carry bit or carry is a bit which is forwarded to next significant bit during addition. So here 4 plus 8 is the 12. In this 12 we actually forward this 1 to the next significant bit. That's why 1 is called carry, 2 is called sum. So for any addition we have two outputs, uh, which are carry and sum. Okay. Now, so 4 plus 8 is 12. So 1 is forwarded here, 2 is written here. So 2 is called sum, 1 is called carry. Now 2 plus 1, which is 4. So in this way we can perform addition. Okay. So let us see one more problem. So 24 plus 98. So I want to perform the addition of these two numbers. 4 plus 8 is 12. Out of the in this 12, 1 is carry and 2 is sum. Hence I am writing 2 here, I am writing 1 here. Okay. Now what is 1 plus 9, 10, 10 plus 2, 12. So again we are getting 12. In this 12 also 1 is carry, 2 is sum. So 1 is carry, 2 is sum. Hence the addition is 122. But here if you observe the addition of these two digit decimal numbers is not giving a 3-digit result. Okay. So we cannot accommodate also what the fact that we need to understand is in addition of any two numbers, it may be binary or decimal, whatever it may be, there are chances for overflow. Overflow means a n bit addition of two numbers may not give n bit result. It can give sometimes n plus 1 bit result. Okay, so that's the fact that we need to consider before performing addition operation. Now let us do the addition of binary numbers. So the addition of binary numbers follow some rules. So that rules can be understood with the help of truth table. So that's why I'm considering A as one of the bit, B as another bit. I want to add these two bits. Okay. So if I want to add these two bits, I can get two results or two outputs. One is a sum and another one is a carry. Okay. So A and B are the bits that are to be added, binary bits that are to be added. S and C are the outputs. S means a sum, C means carry. So that we need to understand. Now, so what are the how can you fill this truth table? So with A and B, I can have four possible combinations because A and B are two variables. So with two variables, I can have four combinations. With n variables in general, with n variables or n inputs, I can have 2 power n combinations. I can have 2 power n combinations. Okay. Now here, what are the variables a and b? So two variables. How many possible combinations? Two square combinations. Two square means four combinations. So 0 0, 0 1, 1 0, 1 1. So these are the four possible combinations. Now for each combination you have a specific output for sum and a specific output for carry. Okay. So when you want to add 0 plus 0, sum will be 0, carry will be 0. When you want to add 0 1, sum will be 1, carry is 0, because there is not overflow, or it is intuitive that the carry is not going to generate in this 3 combinations, first 3 combinations, because 1 and 0 is also having sum as 1, carry as 0. Okay, for all these 3 combinations the carry is 0, because it is actually intuitive. If you want to add 0 and 1, it will be 1, 1 and 0, it will be 1. So and here the last one is quite somewhat different, 1 1. So 1 plus 1, so 1 plus 1 is actually sum is 1, sorry, sum is 0, carry is 1. Okay, so 1 plus 1 generates a carry 1, which is forwarded to next significant bit, and sum is 0. So this is the only thing which you need to keep in your mind, which is very very important. Okay, so in binary addition, if you want to add two high outputs, the sum will be sorry, if you want to add two ones, the sum will be 0 and the carry is 1. Okay. So this is a very important thing that we need to keep in mind. Right. Now let us go to various numericals with which we can easily understand the binary addition in a proper way. Okay. So let us add. I want to add 0 1. This is one binary number, and I want to add one more binary number to it. So let us find what is the result of this binary addition. Okay. So 0 1 1 0. So 1 0, 1 plus 0. 1 plus 0 is 1. Sum is 1. There will be no carry. 0 plus 1, sum is also 1, and there will be no carry. So this is the result. What is 0 1 is equivalent to? It is a 2-bit binary equivalent for 1, decimal number 1, and it is a 2-bit binary equivalent for the decimal number 2. Okay. So 1 plus 2 is actually equal to 3. So 3 is a decimal equivalent for the 2-bit binary 1 1. So this is the answer for our question. Let us go to the second question. So 1 1, this is the binary, and I want to add this with to one more binary 1 0. So I need to know what is the result. Okay, so let me do it. So 1 1 is one binary number given in the problem, and 1 0 is another binary number. Okay, so when you want to add these two, 1 plus 0, so sum is 0, there will be no carry generated. 1 plus 1, so carry is generated, sum is 0. Okay, so you need to write the carry down again. So this is the carry which is generated, and it is forwarded to the next significant bit, and as there are no next significant bits further, so I have written that it as it is at the most significant bit position, and the sum of these two is 0, and the sum of these two is 1. So the result is 1 0 1. Okay, so you can easily check your answer. So 1 1, so 1 1 is the 2-bit binary equivalent of 3, and 1 0 is the 2-bit binary equivalent of 2. So 3 plus 2 is equal to 5 actually. So 5 cannot be represented with the 2-bit binary. Okay, so 5 cannot be represented or cannot be specified, cannot be represented with 2-bit binary equivalent. So with the 2-bit binary, so we are taking now extra bit in order to represent this 5. Hence, so 101 is nothing but a 3-bit binary equivalent. So it is a 3-bit binary equivalent of 5. Okay. So this is the answer. 101 is your answer. Okay. So next, let me go to some 4-bit addition. So with that you can understand easily. So 1010. So this is the binary number 2 with base 2. Next I want to add these to 0 0 1 1. Okay. So this is the 2. So if I want to add these two binary numbers, how can I do this? So let me write 1010 0011, add these two binary. So 0 plus 1, so no carry will be generated, so the sum is 1. 1 plus 1, so carry will be generated and the sum is 0, so carry is written here, sum is 0, and 0 plus 0 plus 1 is 1. Similarly 1 plus 0 is 1. Okay. So this is the result. In order to verify your answer whether it is correct or not, 1010 is the 4-bit binary equivalent of decimal number 10, and 0011 is the 4-bit binary equivalent of 3. So 10 plus 3 is actually equal to 13. Here 1101 is also nothing but 4-bit binary equivalent, 4-bit binary equivalent of. Okay. So in order to understand the by equivalent binary bits, you can make use of simply um, 2-1 code for 2 bits, 2 bits, 4-1 code for 3 bits, next 8421 code for 4 bits. Like that, you can also have 168421 code for 5 bits. Okay, if you have a binary number of 2 bits, you can consider MSB, means you can multiply the MSB bit with 2 and the LSB with bit with 1, you will get its decimal equivalent. Similarly, if you have a 3-bit binary, multiplying MSB with 4, next significant bit with 2 and the least significant bit with 1, you will get equivalent decimal number. Similarly for 4 bits, similarly for 5 bits, you can easily convert them into its equivalent decimal number. Here, as these two as well as the result, as the two numbers as well as the result, all these are 4-bit binary numbers, we can use 8421 code in order to find their equivalent decimal values and then verify your answer. Okay.